Okay, today guys we're going to talk about exponential functions, and you should be familiar with this from your toolbox. Y equals a to the x. You know the shape of it from that. And today I'm going to add something kind of to that. I'm going to use a different look on occasion. Another way to have a generic exponential function is a times b to the x. In that case, b is where the a would have been over here with the exponent of x, and that is your base. The a in this situation is your y-intercept, where it's crossing the y-axis. As you learned when we did our toolbox function graphs, this one crosses at 1. There's an understood 1 out here. So I want to make you write down that this is the y-intercept. Take note of that. And then b is also very important. B can be some different numbers. If b is greater than 1, so b is greater than 1, you have an increasing graph. We can call that growth because a lot of times exponential functions can be applied to money or bacteria or things like that, populations that are growing. And that happens when this number here is greater than 1. If it is between 0 and 1, it is decreasing. That can be known as decay. So like your car depreciating when you drive it off the lot. Half-lives, if you've studied half-life of carbon or things like that. Those are decay situations. So to talk about the graph for a second, the regular a to the x that we learned, that would be the situation where b is greater than 1, where your base is greater than 1, our a is greater than 1 that we learned. That is a growth graph going up like this. We have a horizontal asymptote over here that I'll talk about in a minute. But in our case, that's going to cross at 1. Now, when the b, again, is between 0 and 1, it should be decreasing or decay. It's basically the flip of that. It's going to come down like this. It's going to be going downhill, getting smaller and smaller and smaller. And both of those I have crossing at 1. If we were in this format, you know, your a would be 1, but we don't typically write 1 times something. That's why I talk about it like this. On these graphs, whether it's a growth or decay, you do have a horizontal asymptote because for a growth graph, this end is getting close to 0 but never crossing it. And for a decay graph, this end is getting close to 0 but never crossing it. So you do have a horizontal asymptote. And that is going to be at 0. That horizontal asymptote is at y equals 0. Unless you shift the graph up or down, which we'll talk about later. So unless shifted up or down. You will have that horizontal asymptote. And so that is your basic information that you need to know about the basic equations and the basic graphs. Okay, we're going to go through a couple of different types of problems today, and one of those is going to be when the directions say evaluate, and just like before, evaluate means plug in. So our first example is going to look like this. You have a function f of x equals 2 to the x, and you have x equals negative 3.1. So this will be given to you, and all they're asking you to do is plug that in. So using function notation, this what's inside parentheses is going to tell us what we're plugging in, and I'm going to stick that in for x. We've done this with lots of other things before. At this point, you're ready to type into your calculator. It's not something that you're going to know off the top of your head because this is a decimal. So if you plug it into your calculator, you get 0.116. Okay, here I have another example. F of x equals 2 to the negative x, and x is pi. So again, using function notation, you want to plug in what that you are plugging in. You stick inside the parentheses, and I'm going to show you that I'm putting that to the negative pi because I had a negative in front this time, which would change the sign since it was positive pi, now it's negative. And again, that's something that I don't know off the top of my head, so I'm going to use my calculator to get it. They are fully expecting you to use your calculator in these types of things. Okay, something else that you'll be asked to do is to sketch. And here I have a basic example, one that you should know. You've done your toolbox functions. This just gives us a number where we normally would have a. And you need to know that since it's greater than 1, it's a growth graph. Those things that we talked about at the beginning will come into play now. And so this graph, a sketch of this graph would look like a exponential growth. Its y-intercept would be at 1. Okay, so some of you might say, well, what happens when the number gets bigger? So it's the same kind of case. It's exponential growth. We just have a 2 changing to a 4 here. All it does is make it steeper. And, you know, as humans, we're not perfect. It's kind of hard to draw, so I'm just going to make an effort at it. It's not going to go straight up. It's just really hard to draw. So it's still going to cross at 1. I'm just going to make a note that it would be steeper than the 2. The bigger the number, the steeper it's going to get, the faster. It's also going to get closer to 0 faster over here. Okay, for our third example, I wanted to show you what some other things do. We've moved graphs left and right and up and down before when we talked about our functions unit and when we talked about quadratics. This is considered the inside when you are in the exponent of an exponential function. So this would be where you would discuss moving right or left. In this case, the plus 1 means that we're going to move left 1. Now, on the graph, when you're sketching that, we know the y-intercept, so I know that normally it would cross here. If I move left 1, it's going to go through this point here. And I just want to make sure that I do that. That's the best option that I have. Example 6 shows a change on the outside. This minus 2 is not in the exponent, so that's considered the outside. And as you know, outside deals with y's. That's where you move up and down. So this being a minus 2 means that we are going to be moving down 2. So again, I know my y-intercept is normally 1. So I want to move that down 2. So that would be at negative 1. And I also had a horizontal asymptote at 0, so that's going to move down as well. And so it will now be at negative 2. So I'm going to have my horizontal asymptote there. I'm going to go through the point at negative 1, and that will be my new graph. Okay, on this next example, I have added a negative in. This negative is not in the exponent, and therefore is considered on the outside. And that does what they normally do on the outside. That's going to give us a vertical flip. So this is going to look different than anything that we've seen yet, because, you know, normally your exponential graph would go up like this. A vertical flip is going to flip it down. So it's now going to cross at negative 1. You still get close to 0 on the left side, but you're going to grow down on the right side because of that flip. So vertical flip. Okay, now I'm going to move the negative to the inside in the exponent, which means that's going to be a horizontal flip. And that means we're going to flip over the y-axis left and right. So normally this 3, being a growth graph, would grow up like this, but I'm going to flip it left and right. So it's actually going to look like a decay graph. And the reason it looks like a decay graph is because the negative exponent makes is when we have fractions. So this equation and the equation y equals 1/3 to the x are the same. And this is a decay graph because this number is between 0 and 1, telling us that it's going downhill. And again, these two things are the exact same thing if you compare the algebra. Okay, for our next example, we're going to look at one with several changes. We have this plus 3 on the end, so that is where we're going to move up 3. And the negative on the inside does what it did over here, so that's going to do a horizontal flip. So you want to make sure that you include both of those things in your graph. Well, if we move up 3, your y-intercept normally being at 1 is now going to be at 4. So I want to make sure I go through that point. You also need to make sure you move your horizontal asymptote from 0 up to 3. So that will be right here. And then again, the negative makes it have a horizontal flip. So we should be going downhill this time. And there is our basic graph. Okay, for our next example, we're going to look at another one with a couple changes. The minus 1 on the outside says we're going to move down 1. The negative in the front says that we're going to have a vertical flip. So I like to make notes of what I'm doing. Vertical flip and down 1. So when I go to sketch it, if I'm moving down 1 and I normally am going to cross at positive 1, you would think I'll be crossing at 0. But I've also got to deal with this vertical flip, which is going to change all that. So let's take a couple different things. Let's do the intercept, let's do the horizontal asymptote move down 1. So instead of 0, it's going to be at negative 1 because, you know, that's what we're going to really flip over here. And so if I had moved that normal graph down 1, I would be going through 0. However, I am doing a horizontal flip. So that's going to flip it to down here. It's going to actually have an intercept at negative 2. Not a horizontal flip, a vertical flip. So it's going to have this shape. I have, again, moved it down 1 and flipped it vertically. So I'm crossing at negative 2. I have a horizontal asymptote at negative 1. I'm approaching it on that end, and I'm going steeply negative on this end. Okay, I wanted to show you an example that had a base that was between 0 and 1, and so this is a base of 1/2. And I just want you to remember when that happens that it is a decay graph. It's going downhill. This one doesn't have a number in front, and so it's going to cross at 1, but it's going to go downhill. Your horizontal asymptote will affect it on the right side. It will go up toward infinity on the left side. Okay, for our last example, I wanted to show you what happens when you have something of the form a times b to the x. Our base here is 3, so it's a growth graph. And this 2 is your new y-intercept. So when you go to sketch, instead of crossing at 1, you're now going to cross at 2. And again, it's growth. So it's going to go in this direction upward. It's going to get close to the horizontal asymptote over here. I do want to point out that just because this is a 2 doesn't mean your horizontal asymptote has changed. You have not moved it up. You have just changed the y-intercept. So it's still going to get close to 0 on this end. The only reason it wouldn't is if you had a plus or minus something out here. So this is what happens when you have a form a times b to the x. Okay, see me for your assignment. Okay, for your last example, I wanted to show you an equation of the form a times b to the x. And here's the graph that I have drawn. You'll notice it's a growth graph because of the 3. And the 2 is, as I said at the beginning, your y-intercept. So you'll be crossing the y-axis at 2 instead of 1. That's the main difference. I do want you to notice, though, how that the horizontal asymptote does not change. It is still getting close to 0 on this end. The only reason your horizontal asymptote would move up or down is if you had plus or minus a number out here. So the 2 just changes your y-intercept. It does not change your horizontal asymptote. You are now done. You can see me for your assignment.